everyone, and welcome back to my channel. And today we're going to have concentration of solution pertaining to molarity. Suppose you add 10 grams of sodium chloride to 100 milliliters of water. Then in a different container, you add 10 grams of table sugar to 100 milliliters of water. Do the two solutions contain the same number of solute particles? No, they do not, because the two different solutes have different molar masses. To compare the number of solute particles in solutions, chemists often use moles to measure concentration. Recall that a mole is the amount of a substance that contains approximately 6.02 times 10 to the 23 power particles of that substance. And molarity is the number of moles of a solute dissolved per liter of solution. So the equation for the molarity will be molarity equals to moles of solute divided by liters of solution. Alright, so let us review the formula for molarity. Molarity is moles of solute divided by liters of solution. Or you can also express the formula of molarity as 2 capital M is equals to N over V, wherein M is for molarity and N is for the number of moles of solute, and then capital V is for the liters of solution. Now, to use that formula of molarity, let us have sample problem. Our sample problem is, a solution is prepared by dissolving 12 grams of sodium hydroxide in water to make 80 ml of solution. What is the molarity of the solution? Alright, so this time let's have the solution for that problem. So first you need to compute for the molar mass of sodium hydroxide. So the chemical formula for sodium hydroxide is given as NaOH. Na is sodium, and then O is oxygen, and then H is hydrogen. Now, in order to compute for the molar mass, you need to multiply the number of atoms of each element to its atomic mass. So, like for example, sodium, it doesn't have a subscript, so that means it has one atom. So you have to multiply that 1 to 23, which is the atomic mass of sodium. And then for oxygen, we have also 1, and then gonna multiply that to atomic mass of oxygen, which is 16. And then hydrogen is also 1, and multiply that to its atomic mass, which is 1. So next thing that you're going to do is get the product. 1 times 23 is 23, and then 1 times 16 is 16, and then 1 times 1 is 1. And then you add 23 plus 16 plus 1 will give you 40 grams per mole. So that is your molar mass. But our concern is we need to get the number of moles of solute. So in that case, we're going to multiply the given grams to the molar mass, the reciprocal of the molar mass. So in that case, number of moles of solute will be equal to 12 grams times mole over 40 grams. So we can cancel grams and grams. So you will get 12 times mole, 1 mole over 40. That will be 12 over 40, and that will give you 0.3 mole. So that is the number of moles of solute. Alright, since we have already the number of moles, so we can now compute for the molarity using the equation for molarity, which is M equals to N over V. So the number of moles that we solved earlier is 0.3 moles, and then the given volume is 0.08 liters. So we'll just divide 0.3 by 0.08, and that will give you 3.75 mole per liter as the value of molarity.